So in this video we are going to learn about how to construct polar plot and Nyquist plot. In the frequency response analysis chapter, we were having three methods to find out the stability of the system if your system input is having a frequency. Okay, if your input is a sinusoidal in nature, we will be having somewhat another method to find out the stability of the system. So first method is the Bode plot that we have already understood. Next method is the with the help of polar plot and the Nyquist plot. Okay, so how we can construct the polar plot and the Nyquist plot we will see in this particular video. Okay, so what is polar plot and how we can construct it? So what introduction? The definition of the polar plot is the polar plot of a sinusoidal transfer function g of j omega is a polar plot of the magnitude g of j omega versus the phase angle of g of j omega on polar coordinates as omega is varied from 0 to infinity. Okay, so we will be having x-axis and y-axis. Okay, so magnitude versus phase angle, so your y-axis will be your magnitude and you will be having a phase angle as your x-axis of g of j omega and h of j omega. Generally h of j omega we are taking as a unity feedback control system, so we have not written over here. So ultimately you will be having g of j omega into h of j omega. Okay, while we are varying omega is varied from 0 to infinity. Okay, so what we have to do, we have to find out the magnitude and phase angle of g of j omega, and we have to plot it, magnitude on the y-axis and the phase angle on the x-axis, and by varying the value of omega from 0 to infinity. Okay, so as we can see you will be having a magnitude part as well as the phase angle part, so I can write magnitude and the phase angle, it is given as e raised to j. Okay, e raised to j phi, but the phi is in terms of omega, so I will write m into e raised to j phi. It is nothing but the magnitude and the phase angle. Okay, so the plot of the vector magnitude and phase angle as omega is varied from 0 to infinity is nothing but the polar. So generally, the polar plot of the magnitude of g omega is plotted as the distance from the origin, while phase angle is measured from the positive real axis. Okay, generally, we are taking positive angle, we are taking from the anti-clockwise direction. In your polar plot, direction is important, so we will be taking anti-clockwise direction for the positive angle. Okay, the polar plot is also known as a Nyquist plot, but generally it is not that much true. With the help of the polar plot, we can draw the Nyquist plot and vice versa. Once you are having the Nyquist plot or the polar plot, you will be able to draw the another plot, that is polar plot and Nyquist plot. Okay, so first we will see how to draw a polar plot, and then we will be finding out how can we draw Nyquist plot. Okay, so first, where there are the various standard steps to draw the polar plot. Okay, so first step is to determine the transfer function g of s. Whatever the system is that we will be finding out in terms of a s domain. We will find out the transfer function. Now in the step number 2, what we will do? We will be putting s is equal to j omega. Okay, so whatever the answer we have got, we will put s is equal to j omega. Then I will find out the value of magnitude of g of j omega from 0 to infinity by putting limits. Okay, first I will finding out the magnitude and I will put the limit omega tends to 0 and magnitude, and another one is limit omega tends to infinity magnitude of g of j omega. This will be the step number 3. We are finding out the magnitude from 0 to infinity by putting the some limits. Similarly, we need to find out the phase angle. So it is nothing but the phase angle of g of j omega by putting omega is equal to 0 and omega is equal to infinity. So I will be putting limit omega is equal to 0, angle of g of j omega, and limit omega is equal to omega tends to infinity, angle of g of j omega. Okay. So why it is required? It will be starting and ending point of your polar plot. As we all know that polar plot, it is nothing but omega is varied from 0 to infinity. Okay, so for that what we will do, we will be finding out the magnitude part at omega is equal to 0 and at omega is equal to infinity, and phase angle at omega is equal to 0 and omega is equal to infinity. So this will give me the value of starting of the plot from omega is equal to 0, ending of the plot at omega is equal to infinity for the magnitude as well as the phase angle. Now we need to rationalize the function g of j omega and separate the real and imaginary parts. How we can do? We will see with the help of example. Then in the next step, what we have to do? We have to put real part is equal to 0. Okay, if we are putting real part is equal to 0, we will determine the frequency at which the plot will intersect with the imaginary axis. We are putting real part is equal to 0. This will give me at which frequency the plot intersects imaginary axis. Okay, and we will calculate the intersection value by putting the above calculated frequency in g of j omega. Okay, just remember, we will put real part is equal to 0. Whatever the answer in frequency we are getting, it will give me the intersection with the imaginary axis. Real part ने 0 करो तो imaginary axis ने intersection की आपसे. In the step number 7, we will put imaginary part is equal to 0, and whatever the frequency we are getting, this frequency is nothing but the intersection with the real axis. And again we can calculate the intersection value by putting the above calculated value in g of j omega. So now in from step number 3 and 4, we are having a starting and final value of magnitude and phase angle plot. And in step number 6 and 7, we are having intersection point, intersection with your imaginary axis and intersection with your real axis. Okay, so we can complete it. Okay, so this we need to find out the values only. So frequencies as well as the starting and ending point of your g of j omega in terms of a magnitude as well as the phase. Okay, now I will go one by one for the different types of system. So I will take type 0 system. So as we all know that if GS is equal to T upon 1 plus ST1, 1 plus ST2, it is type 0 system. Why? Because S raised to J, J ની value के लिए it is J is equal to 0. That means it is type 0 system. So now what I will do, this is transfer function is ready with us. What I will do, I will put S is equal to J omega. So I am putting it over here, T upon 1 plus J omega into T1, 1 plus J omega T2. Now I will find out the magnitude and the phase angle. Okay, for finding out the magnitude, okay, numerator it will be under root k square plus 0, so it is nothing but k. In the denominator it will be under root 1 plus real part square plus imaginary part square. Imaginary part is this omega t1 whole square, and this one under root 1 plus omega t2 whole square. Okay, so we are having these two terms. And the angle is what? Actually this angle is nothing but 0. Okay, and in the denominator it will be tan inverse omega t1 and tan inverse omega t2. But if we are putting in terms of a, if it is a divide by 0 numerator divided by denominator, so it will be minus is coming, so it will be minus tan inverse omega t1 and minus tan inverse omega t2. Okay, so that you need to take care. So minus and this one. Okay, this minus is coming because it was actually in a denominator, but it is going in a numerator, so it will be minus tan inverse. Now what will be the step number 3? Step number 3 is what? We have to find out limit by putting omega tends to 0 and omega tends to infinity, and we will find out the magnitude of g of j omega. So this will be my step number 3. Okay, for step number 3 we will taking the limit of magnitude g of j omega. Okay, so we will be putting this equation over here. Limit omega tends to 0, magnitude of g of j omega is equal to what? K upon under root 1 plus omega t1 square under root 1 plus j omega t2 square. Okay, that we already we have got this. Okay, so we have found out this. Now I'll put omega tends to 0. If I'm putting it over here, it will be 1 plus 0, 1 plus 0. So answer will be your K. The same, I will go for limit omega tends to infinity. Angle of G of j omega is equal to K upon under root 1 plus omega T1 whole square. Okay, under root 1 plus j omega T2 whole square. Okay, if I'm putting infinity over here, 1 plus infinity, 1 plus infinity, it is nothing but K upon infinity. It is nothing but something upon infinity is nothing but your 0. Okay, similarly, in the step number 4, what we have to do? Again, we have to put the omega is equal to 0 and omega is equal to infinity by putting some angle. So angle of G of j omega, what I will do? I will put this limit. Okay, limit omega tends to 0 and omega tends to infinity. So what we will do? We will be putting limit over here. So limit omega tends to 0, angle of G of j omega is equal to what? Angle of minus tan inverse omega T1 minus omega T2. Putting omega is equal to 0 and inverse 0 and inverse 0. So answer is equal to 0. Now putting omega is equal to infinity. In the same equation, if I am putting omega is equal to infinity over inverse infinity, tan inverse infinity, maybe tan inverse minus 90, minus 90, minus 90, minus 90, it will be minus 180 degree. So what we have got? Magnitude starting point is K. Starting point, why? Because omega is equal to 0, infinity 0. That means starting point is K and ending point is 0. It will start, magnitude plot will start from K and ends at 0. Phase angle will start from 0 and ends at minus 180 degree. So this thing we need to plot. We have got the starting and ending point for both magnitude and phase angle part. Now, what is the next step? Next step is what? We have to first rationalize the function g of j omega and separate the real and imaginary parts. So, what is the rationalization? Rationalization, that means we have got this pure form. Okay, this pure form we are having, that is k upon 1 plus j omega t1 plus 1 plus j omega t2. We have to multiply and divide by complex conjugate of this one. Okay, so what I will do? I will multiply it by 1 minus j omega t1 and 1 minus j omega t2. Okay, multiply and divide. Okay, and if you are taking further calculation, so it will be square અહીંયા square થશે. So we will be getting this answer. Okay, we will be having this answer and we have to separate it out. Whatever the answer we are getting, we need to separate it out. So how we can separate it? We will be having some real parts and some will be having a imaginary part. So this is nothing but your real part. So this is your real part and this is your imaginary part. Now step number 5 is what? Step number 5 or the 6 is we have to put real part is equal to 0. Okay, for that what you have to do? You have to take the real part is equal to 0. That means this part is equal to 0. K into bracket 1 minus omega square t1 t2 divided by 1 plus omega t square t1 square plus omega square t2 square plus omega square omega raised to 4 t1 t2 is equal to 0. So this particular denominator is going to be multiplied by 0. So that means k into 1 minus omega square t1 is equal to 0. Okay, and further if I am multiplying, we will be having omega because we need to find out omega. In the step number 4, what step number 6, it is written that determine the frequency. So what we will do? We will make the subject as a frequency. Okay, so we will make the subject as a frequency. So we will be having omega is equal to 1 upon omega square is equal to 1 upon t1 t2. Okay, so we will be having omega square, so it is going to be in under root. So we 1 upon under root t1 and t2. Okay, I am taking this only. Okay, and another one is what? Either this term is going to be 0, this term is going to be 0 when you will be having omega is equal to infinity. So here omega infinity muku, so this term is going to be, we will be having two values. either your omega is equal to under root t1 t2 1 upon under root t1 t2 and omega is equal to. So now we have got this omega is equal to under root t1 t2. This particular omega we have to put in our g of j omega equation. Okay, if I am putting this omega over here, so it will be a under root t1 t2 divided by t1 plus. What all I have to do is we have to find out g of j omega. અહીંયા જે g of j omega મળ્યો ને, okay, g of j omega, we have to put omega is equal to under root t1 and t2. Okay, so if I am putting omega is equal to under root t1 t2, I will be getting this answer, and the angle is minus 90 degree. Okay, we have to put in this equation. Sorry for this. We have to not to put in this equation. You have to put in this equation. Omega is equal to under root t1 t2. Okay, and omega is equal to under root t1 t2. If I am doing so, I will be getting, okay, k under root t1 t2 divided by t1 plus t2 due angle of minus 90 degree. Okay, and same way if I am putting omega is equal to infinity, okay, I will be getting g of j omega is equal to 0 under root 180 degree. Okay, so that you have to do. A omega is equal to infinity, k upon infinity, obviously it will be magnitude part will be 0 in something divided by infinity, and tan inverse infinity and tan inverse infinity, so it will be minus 90 minus 90, so it will be minus 180. So we have got the omega whose value is under root t1 t2 and omega is equal to infinity, and the phase angle minus 90 and minus 180. So what it indicates, what does it indicate? It is written that it is the frequency at which the plot intersects the imaginary axis. We have made real part is equal to 0, so we have got imaginary axis intersection with the imaginary axis, and we will calculate the intersection value. Even if it is intersecting, we have got the frequency only, but at which particular point it is going to intersect, we have to put in g of sigma. So that value we have got in this equation. Okay, so આ point ઉપર આટલા magnitude ઉપર a intersect થશે at which angle -90. Okay, similarly for omega is equal to infinity, we have put real part is equal to 0. In the next step, what we have to do? We have to put imaginary part is equal to 0. What is the imaginary part? K omega t1 plus t2, 1 plus omega square t1 plus omega square t2 plus omega raised to 4 t1 into. Okay, we have to put is equal to 0. So again this will be 0, or this whole term is going to be 0 if I am putting 0 over here. So either omega is equal to 0, or if I am putting infinity over here. Okay, if it is infinity, something divided by infinity, okay, something divided by infinity is nothing but 0. Okay, so there will be two possibility, either will be putting plus or minus infinity because it is a square term. So if I am putting plus infinity or infinity, you will be having. So what I will do, I will put omega is equal to 0 and plus or minus infinity in our main equation. Which is one is our main equation? In this equation, omega is equal to 0 and omega is equal to infinity. Okay, if I am putting so k upon z 1 plus 0 square 1 plus 0, so your answer will be k. So what answer you are getting, that is k. And if I am putting 0 over here, okay, again I will put 0 over here, tan inverse 0 tan inverse 0, I will be getting answer as 0. Similarly if I am putting infinity, so I will be getting 0 angle 180. Okay, what does this indicate? It is gives the frequency at which it intersects your real axis. Okay, at which value? K and 0. Okay, omega is equal to 0 હશે તો k ઉપર ટચ થશે, omega is equal to infinity હશે તો 0 ઉપર થશે. Similarly, what does it indicate? If omega is equal to 0, it will touch at this magnitude and this phase angle, if omega is equal to infinity, it touches to 0 magnitude and the phase angle is minus 180 degree. Okay, so what we will start, okay, we will start drawing the polar plot. Okay, so as we all know that polar plot definition, the polar plot of a sinusoidal transfer function g of j omega is a plot of magnitude g of j omega versus the phase angle of g of j omega on polar coordinate as omega is varied from 0 to infinity. So what we have to do, we will be taking one axis as your magnitude axis and one axis as your phase angle. Okay, so we will be having starting and ending point. What is the starting and ending point for our function? Starting and ending point we have got for magnitude, starting is a, ending is 0. For the phase angle, starting is 0 and ending is minus 180. Okay, during this journey what will happen, it is going to intersect with the real axis as well as the imaginary axis. First we have find out intersection with imaginary axis. It will intersect the imaginary axis at this frequency. Okay, if it is intersecting the imaginary axis with this frequency, when this magnitude is this and the phase angle is this, similarly the magnitude is this and the phase angle is this. Okay, the polar plot will again intersect with your real axis, that we have found out by putting imaginary part is equal to 0. Polar plot will intersect at frequency 0, at frequency is equal to 0, and whenever it is touching, the magnitude of intersecting with real axis is nothing but a, and the phase angle is 0. Okay, so now I will draw the polar. For drawing the polar plot, there will be a two axis. First one is your imaginary axis and another one is your real axis, real and imaginary. So as we all know that we are drawing the polar plot for your magnitude and the phase angle. So phase angle we will starting in an anti-clockwise way. Okay, so it will be 0, minus 90 degree, minus 180 degree and minus 26 to 70 degree. What is the starting point of polar plot? Starting point of polar plot for the magnitude part, k, ending is 0, phase angle is 0 and ending is minus 180 degree. It will start from k. Is k positive? Yes. Ending is 0. Okay, so it will start at, let us say this value is this. It will start at k. It will ends at 0. એટલે અહીંયા આવશે, એટલે મને starting અને ending point ખબર પડી ગઈ. Now again, if it is starting and ending point of magnitude, we have got starting and ending point magnitude a and 0. k આવશે ત્યારે phase angle કેટલો હશે? 0. And if it is ending point is 0, your phase angle is minus 180 degree. Okay, so when it is coming to 0, it is minus 180 degree. It is 0 આવ્યો, it is at minus 180 degree. Okay, at 0 k ની value છે, so your phase angle is 0 degree. At infinity you are having answer 0. So now next step is what? It is touching to imaginary axis. If it is touching to imaginary axis, which frequency it is touching, that we have calculated. It is omega is equal to under root t1 t2. Okay, but what will be the value? Value is what? Magnitude is k upon under root t1 t2 divided by t1 plus t2, but the angle is minus 90 degree. Okay, minus 90 degree ઉપર તમારે આ find કરવાનું. What does that mean? At minus 90 degrees, so it will be intersecting over here. Okay, at this frequency it will intersect. What will be the magnitude of this? So this will be k under root t1 t2 divided by t1 plus t2. Okay, next step is what? it should be touching to the real axis. So we have found out this. It will be touching to the real axis at omega is equal to 0, and the magnitude will be k, and at infinity it will be 0. So that we have already done. It will be touching to the real axis at omega is equal to 0, magnitude is k, phase angle is 0. It will touch to the at real axis at omega is equal to infinity when your magnitude is 0 and phase angle is minus 180 degree. So that we have, it will start from over here. So my, okay. So in your example, it might happen that you will be asked in this manner for GS is equal to 20 upon 1 plus 1 plus 2s, okay, another bracket 1 plus 3s, then this T1 and T2 are nothing but your coefficient of your s. Okay, so that is 2 and 3 that you have to calculate. Okay, so this is the generalized term. This is the basic terms associated with your type 0 system. For all the type 0 system, your curve will be looking like this only, but the values will be varying. Okay, if it is 20 upon 1, 20 upon 20 upon 1 plus s2, 1 plus 3s, so the value of this is going to vary, the value of omega is equal to vary, the value of k is going to vary. Okay, so this is the standard form of your type 0 system polar plot. So this shape you need to remember, a type 0 no shape how. Next I will go for type 1 system. Okay, so I will take example over here. Okay, suppose you will be having GS, okay, 1 upon 1 plus s, 1 plus 2s. So first step we will be replacing s by j omega, so it will be 1 plus j omega, 1 plus 2 j omega. Next step is what, either we can first rationalize or we will be putting limit over here. So first I will rationalize, so we will multiply and divide by complex conjugate of this. So I will multiply and divide by 1 minus j omega and 1 minus j2 omega. Okay, if I am doing so, I will be getting this terms. Okay, if I want to separate it out. Okay, so first will be your real part and second one will be your imaginary part. Next, what I will do, I will put omega is equal to 0. Okay, if I'm putting omega is equal to 0, I will be getting this term. Okay, there is the intersection with your real axis. Okay, sorry, I will be putting real part is equal to 0 in this. So what is the answer? It will be 1 minus 2 0 square. So it is nothing but your 1 minus j 0. It will be again 1 plus 0, 1 plus 0, it will be, and for infinity you will be having minus 0 minus 0. So this will give me the intersection with your imaginary axis. Okay, similarly we will find out the intersection with your real axis also. Okay, so now that we can find out with the help of real axis, but if you are solving it, it will not intersect with your real axis. Okay, if we are doing the same calculation will be applicable, and then we will find out omega. Okay, that omega is equal to 1 upon under root 2. The question the equation was under root t1 t2. Okay, so if I'm putting omega is equal to under root t1 t2, so it will be 1 into 2, it is nothing but under root. Okay, and then we will find out the value of g of j omega by putting omega is equal to 1 upon under root 2. So as we know that it will be having a k. So what is the value of k? K is nothing but 1. It is starting from over here k at 0 degree. It will be having omega is equal to under root 2. Okay, and what will be the distance over here? The distance over here is nothing but this a under root t1 t2 divided by t1 plus t2. Okay, so you have to put 1 over here under root 2 divided by 1 plus 2. So whatever the answer you are getting, it will be coming over here and you have to 0.4347. So it will be okay. So this is your type 0 system. Similarly for type 1 system, what is the difference over here? You will be having another extra s over here because s raised to j value is 1 over here. So again the same steps are there. Put s is equal to j omega. So you will be having one extra j omega over here. Then I will find out the magnitude and the phase angle. Okay, so the magnitude will be k upon omega divided by under root k upon under divided by omega under root 1 plus omega t square under root 1 plus j omega t square. Okay, 1 upon something, it is nothing but j omega, it is nothing but minus 90 degree minus tan inverse omega t1 minus tan inverse omega t2. Okay, there was a no real part over here, so we will be having a minus 90 degree. Okay, minus came out because it is on numerator side. Next step is what? We will be putting some limits. Okay, limit for the magnitude part and the phasing. Okay, taking the limit of magnitude, if I'm putting omega is equal omega tends to 0, we'll be getting infinity. Omega infinity tends to infinity, it will be 0. What does that mean? If omega is equal to 0, it will be at infinity. It will start from infinity and at 0 for the magnitude. Again, taking the limit of phase angle, it will be starting from minus 90 degree and omega is equal to infinity and at minus 270 degree. So we have got the starting and ending point of magnitude and the phase angle. Starting will be infinity, ending at 0. Starting angle is minus 90 degree, ending angle is minus 270 degree. Okay, in between this, it is going to be touching at real axis and the imaginary axis. Okay, so for that what we have to do, we have to rationalize the terms. That means we have to multiply and divide by complex conjugate of this. Okay, so if I am going to multiply it and separate it out, we will be getting real part of this and the separate imaginary part of this. Next step, what I will do, we will put real part is equal to 0. So this part if I am putting 0, okay, then this will be 0 if we are having omega is equal to infinity. आपको 0 नहीं था, but if we are putting omega is equal to infinity, then I will put omega is equal to infinity in this main equation. Okay, if I am putting omega is equal to infinity, we will be having g of j omega is equal to 0 angle 270 degree. Okay, so this your polar plot will be intersecting with your imaginary axis at omega is equal to infinity. Okay, and what will be the value? Magnitude will be 0 and angle will be minus 270 degree. Okay, next what we have to do, we have to put this imaginary part is equal to 0. This will give me the intersection with the real axis. Okay, so if I am doing so, it will be like this, it will be 0. So this is going to be 0. Okay, and this term we need to find out. If I am putting 0 over here, so omega is equal to, if I am putting under root t1 t2, or omega is equal to plus or minus infinity. Okay, if I am putting this, you will be having this answer. If I am putting omega is equal to infinity, we have got this answer. So we have got all this now putting into graph paper. So we were having this answer. It is starting from infinity magnitude part, ending at 0. Okay, but which angle it is starting? Minus 90 degree starts as a ending at minus 270 degree. So again we are having this graph. Okay, we will be having a real part and imaginary part minus 90. So it will be coming from infinity. It will be coming from infinity at which angle? Minus 90 degree. Okay, એટલે અહીંયાથી બી આવી શકે, અહીંયાથી બી આવી શકે. Okay, ending at 0. Ending part is your 0. Okay, at which angle? It is minus 270. It will be ending at minus 270. Okay, before starting and ending, it is going to intersect with your imaginary axis as well as the real axis. What was the answer we have got? Intersection with your imaginary axis, that is 0, and which angle? That is 270, minus 270. What is the intersection with your real axis? Intersection of real axis is what? G of j omega is equal to minus k under root t1 t2 divided by t1 plus t2, and what is the angle? 0 degree. Okay, so minus क्या होता है, this is the positive part, this is your negative part. Okay, so it is going to be done. It is, so I will be starting from infinity, omega is equal to 0. It will be going 0 at omega is equal to infinity. It will be touching at omega is equal to 1 upon under root t1 t2 with the magnitude of a upon under root t1 t2 divided by t1 plus t2. Okay, so this is the answer we have. Okay, done. This is your type 1 system. For all the type 1 system, you will be having this shape. So this is the example of type 1 system. 1 upon s into 1 plus s, 1 plus 2s. Again, what we have to do? First, we have to find out the real part. If we have to find out the limits, okay, limit omega is equal to 0 and omega is equal to infinity. Similarly, for we have to rationalize the terms, so it will be 1 upon s into 1 plus s. Okay, so we need to 1 plus 1 minus j omega and 1 plus j omega, 1 minus j omega and 1 minus j2 omega. So we will multiply and divide by both this term, so we will be getting this two terms. So I will separate it out, this two terms. So after separating out, we will be having a real part and the imaginary part. Okay, so we will be putting some limits over here. So we will be getting g of j0 minus 3 minus j infinity g of 0. Okay, so now we need to find out the intersection with the real axis also. Again, we will be finding out intersection with real axis, and this way we will get omega under root 2 1 upon under root t1 t2, the same frequency, and then I will find out this value. It is 0.666 minus 0.666. Okay, so it will be coming from infinity. Okay, that is omega is equal to 0 minus 3 minus g infinity અહીંયાથી it થશે at minus 180 degree. Okay, it will intersect at omega is equal to 1 upon under root 2. Okay, and what will be the distance over here? It will be minus 0.666. તમારું છે left hand side, it will be minus your polar plot. Similarly, you can do it for your type 2 system. For type 2 system, again, what you have to do? You have to replace s by j omega. Okay, your s by j omega, if I am doing so, it will be j omega square, j square is equal to minus 1 answer, so it will be minus અહીંયાથી એક વધારે term આવશે. Okay, that calculation you need to do it by your own, and you will be getting this time. It will be starting from infinity, ending at 0. It will be intersecting with imaginary axis at the frequency of under root t1 t2. Okay, and this you need to find out. It is regarding your type 2 system. Done. Now this is the polar plot. Now we need to find out the Nyquist plot. So how we can do this? Okay, the example of this again s square. j square so minus outside, so it will be minus omega square. Okay, and we need to separate it out. We have got this. This is nothing but your 0.94. Okay, so this is the shape of your type 2 system. Okay, so this is the extra example, that is 20 upon g omega 1 g omega plus 2. Okay, so it is type 1 system. So type 1 system calculation is given. Now we will finding out gain margin, phase crossover frequency, gain crossover frequency for the polar plot, and how to construct the nice night. Okay, suppose we have got this plot. Okay, which type of the system is this? It is type 1 system. So the type 1 system is having a plot of this. Now we will draw the unit circle. Unit circle, that means whose radius is 1. I will draw a unit circle of this. Okay, when your polar plot touches to your unit circle at that particular frequency, it is nothing but your gain crossover frequency. Okay. Next is what? When your polar plot touches to your real axis, this frequency is nothing but your phase crossover. Okay. The angular difference between gain crossover frequency point and minus 180 degree is nothing but your phase margin. The angular difference between your gain crossover frequency point, this one, and your minus 180 degree is nothing but, okay. First one is what? You have to draw the polar plot, then you have to draw the unit radius circle. Then what you have to do? You have to find out the gain crossover frequency and phase crossover frequency. Okay. This is the definition as far as the polar plot concerned. The frequency where a polar plot intersects the my negative real axis is called the phase crossover frequency. Gain crossover frequency is what? The frequency where the polar plot intersects the unit circle is called the gain crossover frequency. Okay, that is nothing but this. Unit circle ने करूँ तो इन्हें gain crossover frequency, negative real axis ने touch करूँ तो इन्हें क्या है phase crossover. What is phase margin? The phase margin is the amount of additional phase lag at the gain crossover frequency required the system to the verge of instability. Or in other words, it will be the additional phase which is required for putting into a marginal stability. Marginal stability पर क्या रहा उसे? जरा minus 180 degree થઈ જશે. So the equation is phi m is equal to 180 degree plus phi. Okay. Now phi is what? Angle of j omega, while putting omega is equal to omega gc. Okay, so this angle we need to find out. Okay, now if I'm finding out phi m, if phi m is positive, that means your system is stable. If phi m is negative, then your system is unstable. Okay, mathematically you can find out the gain margin also, but we have to find out gain margin. We can find out the gain margin by this equation. Okay, the gain margin is a reciprocal of the magnitude at the frequency at which the phase angle is minus 180 degree. Okay, so for that what we have to do? We have to find out the reciprocal of your g of j omega. Okay, but this g of j omega at which frequency? Phase crossover frequency. Oh, okay, so minus 180 degree. Okay, so now if I'm putting, let us say it is 1 upon s, so it will be in terms of putting in terms of a dB, it will be 20 log 1 upon under root g of j omega. Okay, so if it is in terms of g of j omega, denominator માંથી ઉપર જશે minus, so minus is coming over here, minus 20 log this. Okay, and what is the answer? Minus 20 log 1 upon x. Now how we can find out the stability? As I already told you, you will be having your gain margin and phase margin. So phase margin, if it is positive, then your system is stable, and if it is negative, then your system is unstable. Okay, in this way you can find out stable system. Okay, now another point is what? If the critical point minus 1 plus 0 is within the plot, okay, within it is reverse manner. Okay, it is actually the outside of the plot, then both the gain margin and phase margin are positive, so your system will be stable. For unstable system, if your critical point minus 1 plus j0 is inside, not actually the outside, outside is in terms of this, it is inside of the plot, then both gain margin and phase margin are okay. This is the answer. Now, if your minus 1 plus j0 point is on the unit circle, okay, યુનિટ સર્કલનો આ પોઈન્ટ છે -1.0 is on your plot. That means you will be having this critical point and your this point is same. Okay, so you will be having your marginally stable. In this case your gain margin is equal to 0 and phase margin is equal to 0. Okay, so this is regarding your polar plot. Okay, so the Nyquist plot, if I want to draw, what is the difference? Nyquist plot, if I want to draw, it is the inverse of this. Like, we have to provide a mirror on your imaginary axis, not inverse, actually it was a mirror. So it will be coming like this. Okay, 1 minute. It will be coming like this. Okay, similarly over here, if I want to draw it over here, it will be coming like over here. Like over here. For type 0 system, it will be okay. We have to provide the mirror. જે જગ્યાએ હોય એની સામેની બાજુ, it will be a mirror image of this. So this is nothing but your Nyquist plot. Polar plot we have drawn. Okay, the mirror image is nothing but the Nyquist plot. Okay, so these are the reference book that I have used for making this PPT. Okay, so this is two books we have taken. Okay, that is Asan Said. Okay, it is from Catson publication. Only one book I have taken. So this is regarding your polar plot and Nyquist plot. Thank you.